Hi, I'm Charlotte Dickert out here in El Sobrante, California, which is in the San Francisco Bay Area. And for the Lesson 1 assignment, I'll be teaching about the basics of microphone characteristics and selection. So first, let's look at what a microphone does. A transducer is a device that changes one form of energy into another. So a microphone takes the pressure waves of sound moving through the air and changes it into a voltage fluctuation. Then, when the signal is in this electrical form, it can travel through cables to be converted back to a sound wave via speakers or digitized to be read by a computer or other processing system. And there are many types of microphones that can do this. What sets them apart are their characteristics that can color the original sound. So in choosing a microphone, keep in mind the basic functions of capturing sound and converting it into an electrical signal. Start with your purpose to help narrow down the field. And this really comes down to two basic questions. What sounds are you trying to capture and eventually reproduce, and where will you be using it? These two questions then relate to the two key characteristics of microphones: frequency response, which is the sensitivity of the microphone to a particular range of frequencies, and directionality, which is the pattern of where the microphone picks up or rejects sound input. So let's look at the two most common types. Let's first look at some general characteristics of each. The first type is a dynamic microphone, which you often see singers using on stage. In general, these pick up primarily sound immediately adjacent to the head. As such, they do not pick up background sounds such as from monitors, and they're often used in on-stage scenarios. In addition, they don't require any additional power, so they just need to be hooked up to the sound system. The other common type is a condenser microphone, which is usually seen in a studio setting. These are more sensitive than dynamic microphones and pick up a wider range of sound, including more of the ambient setting. These require phantom power to operate. Microphones such as these can be tailored to best pick up certain sounds by having a particular frequency response in the range of frequencies produced by the sound source. For example, a dynamic microphone can be designed to pick up frequencies in a vocal range, but reject frequencies higher or lower than that range. In these types of microphones, the frequency response graph will show a peak at this frequency. For example, this graph for the Audio-Technica Pro 41 shows a peak at around 4 kilohertz, which is in the range of the human voice. Compare this with a flat response graph, such as that shown for the Audio-Technica AT4047SV condenser microphone. Here, the graph shows a more level response from about 1 kilohertz to 10 kilohertz, so it will pick up a wider range of sounds, including those in the background and contributing to the sound of a particular space. The other key characteristic of microphones is the directionality profile, which shows where a microphone best picks up or rejects sound. Although there are several variations, the three main patterns shown here are cardioid, which is also called directional since the pickup region is focused in front of the microphone head. This configuration minimizes pickup from the back or behind or to the sides of a microphone. Therefore, it is most effective at picking up a close, usually singular source of sound, such as a vocalist on stage. This type can also have hyper and super variations, which allow for more sound pickup in the direction opposite the primary direction. The next is omnidirectional. Here, the pickup region is equal in all directions, so the microphone can pick up sounds surrounding it rather than from one direction. This can be used with groups of sound sources or in a studio setting to also capture the sound quality of the space. Next is the figure 8, which provides pickup regions mainly to the front and the back of a microphone, while minimizing sounds from the sides. So, to summarize, dynamic microphones have a peak frequency response and cardioid directionality, so they can be thought of as more focused. Condenser microphones have a flat frequency and are usually omnidirectional, although they can have other profiles, so they provide a broader pickup range. The other major difference is in the power supply. Dynamics do not need any additional power, but condensers require an additional phantom power source. These characteristics determine the best microphone for the job. So which one to choose? It depends on how, where, and for what it's being used, but in general, for capturing more focused sounds without background effects, such as on stage or with a vocal or individual acoustic instrument, a dynamic microphone is probably best. But for capturing a broader range of sounds, such as in a studio setting or with a group or an instrument having a larger sound space, for example, a full drum kit that's not individually mic'd, or to capture the quality of a sound in a particular space, a condenser microphone can be more effective. Hope this was useful, and thank you very much.